Hey everybody! So this video is going to be the first of a couple we'll do. I'll try to keep it brief, to replace class on Thursday. So the idea is that we're continuing our discussion of what we were talking about in class on Tuesday, which is the idea of grade. And we've got some pretty good work now under our belts. The grade, and we've been talking about grades of roads, but it could easily be grade of anything that tips. A lot of times gradient is discussed with rivers dropping and things like that. Although the most time I see it is when they're talking about roads, although it applies to a lot more than that. So we've discovered that grade is equal to the rise over the run of whatever section of road or whatever you're discussing. So the idea is, so far, we've been looking pretty specifically when you have a road. I'll make the road blue. And then you've got the rise and the run, which form 90-degree angles. I'm just going to put a little box right there for a 90-degree angle. So you've got your rise, and you've got your run, and I generally just call the tilted part the road. It's got a funny Greek name called the hypotenuse, but I think road makes more sense. So if you have the rise and the run, then all you've got to do is divide them and get the grade. So for example, if the rise is 3 whatever feet and the run is 4 feet, then the grade is going to be 3 feet over 4 feet, which is 0.75, which is 75%. We did a whole bunch of these in class over the past couple days. So 75% grade. If you need the angle, you can go Google a tangent table and figure that out. And that's all well and good. Totally awesome. But here's the catch. So very often when you use tracking apps, for example, and they give you your elevations, you can't directly calculate the grades from the distances they give you. Because what they give you very often is they give you your elevation change. But then they also give you the distance that you traveled. Now the distance that you traveled is the road. It's not the run, it's the road. So for example, suppose, let's just make some numbers up that are kind of agreeable. Okay, I don't know why I'm using my hand. Let me use my little eraser rag, which I can't find. Oh, here it is. Okay. So suppose you rose 5 feet, just to throw some numbers in there, but the road you traveled on was 13 feet. Okay, now a lot of times I've seen people construct grade what I call the wrong way. This is the right way. This is grade done the right way. But I've also seen the grade calculated the wrong way. So grade the wrong way grade calculations, all you do is you take the rise and divide it by the road. Now, very often those numbers are easily gotten from things like tracking apps. For example, the elevation change is 5 feet and we traveled 13 feet along whatever we traveled along. So the rise over the road is 5 feet over 13 feet, which is 5/13. I can't do that one in my head. Let me do a quick Google calculator. Whoa, I just hit the camera, I'm sorry. As you can tell, I need a staff here. Okay. 5/13 gives us a percentage grade of about 38%. Okay, 38%. Okay, fantastic. But the problem is that that's the wrong way of doing the grade. Technically speaking, we'd have to be able to calculate the run and then do 5 divided by the run. And here's where a little tiny bit of geometry comes in handy. A little tiny bit of geometry. In order to figure out what the run, we can figure out what the run is. We can figure out what this is based on these other two pieces due to something called Pythagorean theorem, which I know we mentioned in class. So Pythagorean theorem. You do not have to memorize that word. It's just, I like giving credit to Pythagoras, even though Pythagoras himself didn't even discover it. But what is credited to him is this beautiful equation. Now, when I asked about it in class, some of you said, oh, it's a squared plus b squared equals c squared. That's great. That's totally great. I've, in all the years I've taught geometry, which was many years before I was here, I noticed that whenever I used a, b, and c, people would confuse it. So I think a better way of discussing Pythagoras' theorem is saying that the rise squared plus the run squared equals the road squared. So in other words, that number squared plus whatever this number is squared equals that number squared. And that for any right triangle, not just this one, but for any triangle that's got a right angle right there, this will work. So for this particular triangle, we can calculate what the run is. Check it now, bear with me here. The rise squared would be 5 feet squared, plus the run squared, which we don't know. We're trying to figure out what that run is. We do not know what that run is, so we're going to leave it as just the word run. Equals the road squared, so that's 13 feet squared. Okay? Now we got to do a little teeny tiny bit of math here. 5 feet squared is going to give us 25 square feet. Now, the units are going to be a little bit goofy, but if you bear with me, you'll get a preview of your first project, which is not due till next week. So this is 25 square feet. In order to make us all kind of happy, I'm going to leave the units off. The board's getting kind of crowded anyway, so just realize the units on that thing are square feet. Okay. Plus, whatever the run is squared, which I don't know because I'm trying to figure out what that is, equals 13 feet squared. 13 squared is 169, so that's 169 square feet. So now you've got this equation that 25 plus whatever we're looking for squared is 169. Now it's a pretty straightforward equation at this point. All we got to do is subtract that 25 from that 169, and if I do that, I end up with 144 if I'm doing the math correct. I'm going to bring this equation back over here. Hopefully this helps. Okay, and I'm going to do run squared equals 144. Let me draw a little line, a little box around all this stuff here. Okay, so all I did was I'm just continuing the solving of the equation over there. Now that's the run squared equals 144 square feet. I got to get rid of the squared by taking square roots. So I'm going to take the square root of both of these bad boys. Okay, and run to the second power, taking the root off is going to cancel the second power, and you're left with just the run. Okay. What's the square root of 144? Well, there's a reason I picked these numbers, because they're actually kind of agreeable. That's 12. Which means that the run of this triangle is 12 feet. Which means that the actual grade is not 5/13. That's the wrong way grade. The actual grade is 5/12. The right way is 5 feet over 12 feet, which I believe, is that significantly steeper? I think it's at least 10% steeper, isn't it? No, not quite. 42%. It's 42%, so it's 6% steeper. So it's about 42% grade. So it's definitely a larger grade because you're dividing by a smaller number. Hopefully that makes sense. If you're dividing by a bigger number, 5 divided by 13 has to be a smaller number than 5 divided by 12. It's the same number of smaller pieces, 13ths versus 12ths. But nonetheless, it's not the same. That's the actual grade. That's the wrong way grade. Now the question, and we can't answer this with 100% certainty every time, is the wrong way good enough? And the answer is sometimes yes, sometimes no. It depends on how much precision you need. For example, one of the quizzes I'll give you next week deals with ADA ramps and the slope of an ADA ramp. Well, that's extraordinarily technical. People can get sued based on that. So you know for sure they're not going to settle for the wrong way when they have to do it the right way. But if you're talking about, plumbing a drain pipe for your garden, this is probably good enough the wrong way. But I just wanted you to realize that when you do grade calculations, that is the correct way of doing grade, rise over run. But very often it's hard to get the run value from the triangle, because when you travel, bike, car, walk, whatever, you're traveling on the road, and that's what your little tracker is keeping track of. It's not like going through the earth and tracking the horizontal. It's tracking the distance you cover on the earth as you move around the surface of the earth, creating these triangles. So this is just a way of rectifying. It's a way of rectifying I keep dropping chalk, I apologize. It's a way of rectifying and finding the run if you're given the hypotenuse and the rise. You have to have two of those things to find the third. And the two that you're most often going to have, almost in 100% of cases, is you're going to have the rise and the run, in which case you just divide them, or you're going to have the rise and the road, in which case you either divide them if the wrong way is okay, which is contextual, or you solve using Pythagoras and figure it out that way. So there's one of two things you have to do. Now I've got some tools here that we can play with to figure out that I'm going to walk you through in the next couple of videos. But I just wanted to get this idea for you on the on YouTube, so you understood the difference between the textbook definition of grade and another way of doing it that isn't always correct. And we'll do more on this in the next couple of videos. So that's good for this one. We'll take some technology questions now and figure this out.